This is question 13, and we're going to be looking at this curve with equation y equals x e to the minus 2x. In particular, finding its turning point here and also finding the area indicated by r in part 2. Let's start with part 1, or part A, I suppose. Part A says, can we find the coordinates of the turning point? So we need the equation of the curve. And our strategy here is to find the coordinates of a turning point. We set dy by dx equal to 0, and that will find us our x coordinate. And then we can find the y coordinate after that. So how do we find dy by dx? How do we differentiate? Something that looks like this. Well, this is the product of two functions. So it is v times du by dx plus u times by dv by dx. Just going to simplify that a little bit. And what we're going to do now is set that equal to 0. Remember, the turning point of a graph is the place where the derivative equals 0. How do I solve this equation? Well, I'm going to factorize out the e to the 2x. Sorry, e to the minus 2x, like that. This can never be 0. It's never possible for an exponential to be 0. So the only place worth looking is here. And if I want this to equal 0, my value of x is 1/2. So once I've found the x coordinate of my turning point, I can find the y coordinate quite easily by plugging it back into the formula we started with. That is 1/2 e to the minus 1, which is 1/2e. So the coordinates of P are 1/2 and 1/2e. Okay, what about part B? Well, part B is asking us to find this region labelled R. Now, my strategy is going to be to find the region labelled A and then take that area away from the rectangle, which is A times B. We're going to start with finding that area A, the integral of our equation. Remember, between 0 and 1/2, I'm finding the area A. How do I integrate something that looks like this? Well, it is integration by parts. It's the product of two functions. I'm going to choose to make that one u and this one dv by dx. And then over here in a little box, I'm going to just keep a record of all the things that I will need to do integration by parts. So you need to differentiate u, you need to integrate dv by dx. That's minus 1/2 e to the minus 2x. This box has now got everything in it that I need. So remember, our integration by parts is going to say uv minus the integral of v du by dx. We'll put some limits in there as well. So uv is x times by minus 1/2 . There we go, that's my uv. And then I'm subtracting the integral of v times du by dx. So that times that is just going to be there we go. Let's do a little bit of simplifying here. So pop the 1/2 into here and you get minus 1/4 e to the minus 1. And then when you put 0 in, you get 0. So nothing to take away there. And then I'm just going to simplify this a bit before I try and integrate it. There we go. Simplify this one a little bit as well. Okay, integral of that is minus 1/2 e to the minus 2x. So now I'm going to just substitute my 1/2 and my 0 into there. When you put 1/2 in there, you get e to the minus 1. And when you put 0 in here, That's going to simplify quite nicely, I hope. So this is minus and minus, so it's plus. E to the 0 is 1, isn't it? Of course, yeah. Wally. So what we've got here is minus 1 over 4e minus another 1 over 4e plus a quarter. So that is minus 2 over 4 minus 1 over 2e plus a quarter. All right, so that, remember, all that work that I've just done on that page was to find the area A. So to find the area of R, it's going to be A times B, so the area of that rectangle. I'll just pop that there, right? So A times by B, the area of the whole rectangle. A times B minus the answer we just found, the area under the curve. So I'm hoping, fingers crossed, that this is going to work. So we've got 1 over 4e plus 1 over 2e minus a quarter. Really spaced that out bad. So make a common denominator, double the top and bottom of that one, and you get 3 over 4e minus a quarter, which is correct. Excellent.